Okay, good morning, grade nines. I'm just going to walk through the two examples that I left for you to work on in groups. Hopefully by now you've completed them yourself and you're just watching the video just to make sure you did it correct. And if you want, you can skip to the very end and look at the answer. If your answer is right, you're probably okay and you can move on. If your answer is wrong, I really recommend watching it again. So about halfway through the video, you'll find the answer to the first one. Go a little bit further, you'll find the answer to the second problem. And just a reminder that on Monday, you have an in-class assignment, which you'll do on your own, and it's open book. So it's kind of like an open book test, and it will count as the test for this unit, and then we will be done all the new stuff, and we'll start reviewing. So let me go ahead and start this problem, and I'll read it first. What is the minimum amount of material required to make a 355 milliliter pop can? So right away, you see units, and you don't know what to do with them, but then you see the note. 1 milliliter equals 1 cubic centimeter. So I would go ahead and I would just say this. The volume is 355 cubic centimeters. And right away, that looks a little more familiar. I know that it's volume because we're filling up a pop can with pop, so it's got to be volume. I also know that we're solving for the minimum amount of material, that is the surface area. So we're looking for the surface area, which means this must be the volume. Obviously, a pop can is in the shape of a cylinder. It's asking us about the minimum amount of material, so we're going to make a pop can that has the same diameter as it does a height. And I'm sure a lot of you are thinking pop cans don't look like that, and you're right. And again, something that was said yesterday sort of gets at why. They want to make the cans look bigger, but we're going to go ahead and assume that we're going to make the optimal pop can. And again, our volume's 355 cubic centimeters. From here, there's one of two directions you can take. You can write out the formula for the volume of a cylinder, and then you can set 355 as V, you substitute it in. The problem you're going to run into is that you're going to have two variables and you're not going to know what to do. So I'm hoping you remember from yesterday that the height is equal to 2 times the radius. And remember what we do. If height is 2r, this h can be replaced by 2r. And after we do that and we rearrange everything, we find that the volume of an optimized cylinder is always 2 pi r cubed. And you can look back at yesterday's stuff if you're not sure how to do that. Okay, so let's go ahead and actually solve it now. As I said, the volume's 355. So 355 is equal to 2 times pi r cubed. We've got to solve for r, so the first thing we've got to do is divide by 2. And I'm sure some of you are saying, well, just divide by 2 pi. And that is what I'm going to do. I divide by 2, I divide by pi. And if I do that, the 2's cancel and leave me with 1. The pi's cancel and leave me with 1. So now I have 1 times r cubed, well, that's just r cubed, is equal to 355 divided by 2 times pi. But I need to find r. So I got to get that little 3 off of there, and I don't divide by 3. I take the cube root. So if I take the cube root of that, and I'm just going to go ahead and perform this calculation on the side, so I'm going to pause the video, and then I'll be right back. And I'm back. And the answer I got for r, I'm going to round it to 2 decimal places. I got r is equal to 3.84. Now I was working in cubic centimeters, and when I cube root it, my cubic centimeters become regular centimeters. So there's my radius, and I'm done. But of course I'm not, because the question is, what is the minimum amount of material? That is a surface area question. So I need to find the surface area. The surface area of a cylinder is 2 pi r squared. Remember, that's the top and the bottom, plus 2 pi r h, and that's the lateral surface. So now what I can do, I can plug in r, I can plug in r. Uh-oh, now I need h. Well, some of you are probably thinking you just double r to get h, and that's absolutely correct. You could do that. You could double r, plug it in for h, and do all of these things, and then in the end, you would get your surface area and it would be correct. However, if you remember what I've already said today, we know that the height is equal to double the radius. I can replace this h with 2r, which ends up making this 4 pi r squared, which makes the whole thing the surface area of an optimized cylinder equals 6 pi r squared. And if you don't remember that, you don't have to at this point because you can plug in 2r, or you can just plug in whatever 3.84 times 2 is and solve it that way. I'm going to do it this way. The surface area equals 6 times pi, and r was 3.84, so I put r in, squared, and again I'm going to pause it and do the calculation. And I get that the surface area equals 277.9 square centimeters. So let me show you the whole thing. There you go. There's all the work that I did on the way. First, I took the volume, I set it equal to 2 pi r cubed, and I solved for the radius. Then I took the general formula for a cylinder, and I put it into this form. Again, this is in yesterday's note. I didn't actually do the work here, so make sure you go back and take a look if you forget. And then once I got this optimal formula, I just plugged in the radius and solved. Once again, your alternate option here is to put in 3.84 times 2 for the height, and you can just solve this as you would regularly. Okay, so that's the first one. I'm 6.5 minutes in, so I'm actually going to stop now, and the other question will be done separately.